This is the second video on section 3.2 lines. And as we're going through the three different versions of the equation of a line, let's keep in mind what we talked about in the last video. So in 3 space, we're going to write the equation of a line. We need a point on the line, and we need the direction of the line. And so our direction is given in terms of a vector. And so the parametric and the vector equations are just three-dimensional versions of what we did in the last video. So for the parametric equation, x is x0 plus at, y is y0 plus bt, and z is z sub 0 plus ct. Where the point, we have the point x0, y0, z0, and the direction of the vector abc. Now, for the symmetric equations, we simply solve for t. So in this case, t is x minus x sub 0 divided by a. T is y minus y sub 0 divided by b. T is z minus z sub 0 divided by c. Now, this is assuming a, b, and c are not 0, of course. And of course, one or more of these components can be 0. What do we do in that case? Well, for example, let's just suppose that our c is 0. Then we would write this the same, but we wouldn't put an equal sign here. We would just write z is equal to z, 0. So this, setting these three things equal to each other is fine when a, b, and c are not 0. When one or more of them is, we have to do something else. And then we have the vector equation. So again, we take as a vector the vector whose components are the same as the coordinates of the point, plus t as our scalar multiple of the vector. And again, this is just a three-dimensional version of what we did in the last video. So let's look at example 78. 2 points to find a line. 2 points to find a line in 2 space, 2 points to find a line in 3 space. So we have these 2 points. How do we find the equation of a line? Well, it's a similar process if we had our 2 points in 2 space. We'd use our 2 points to find the slope, then find the equation of the line like we did in the first video. Here we're going to use our 2 points to find a vector, and then we're going to have a vector and a point and use those to find the equation of a line. So v is the vector 1, 3, negative 3. Where did that come from? This is the vector where this is your initial point and this is your terminal point. And this is our vector. What if you switch them? Well, if you switch them, then you have what I'm going to call negative v. Then you would have the vector negative 1, negative 3, 3. Now remember, lines go in 2 directions, and so it's okay if you use a vector in the opposite direction. So you can use any vector parallel to v that you want as your direction vector. So here's our direction vector. The parametric equations then, 1 plus 1t, or x is equal to 1 plus 1t, y is equal to negative 3 plus 3t, and z is equal to 4 minus 3t. The symmetric equations, solve for t. X minus 1 divided by 1, y plus 3 divided by 3, z minus 4 divided by negative 3, and we can simplify these a little bit. We don't have to write this part. And then here what we did is we took the negative 1 and distributed it through in the numerator, and so we have 4 minus z. And then the vector equations, we take this point, we write a vector using the coordinates of the point as the components of our vector, plus t times our direction vector. When t is 0, we have the vector 1, negative 3, 4, which corresponds to the point 1, negative 3, 4. And when t is 1, then we have the vector 2, 0, 1, which corresponds to the point 2, 0, 1.